Hello, everyone in? Okay. I'll give that team a minute to settle. So, hi, my name is Woochan. I'm currently a final year medical student at Imperial. Before I go in, I just want to kind of get a sense of what's been going on. So, I heard from some of the other mentors that a lot of you are coding quite far into building your idea. So, how many of you are working on healthcare? You don't have to, just out of curiosity. Any teams related to healthcare stuff? Sure, okay, one team. Two teams. Okay, not bad. So what I'm going to talk about is more about what happens after you build an algorithm, whatever that might be, maybe machine learning, deep learning, and how it actually deploys into real life. I'm going to focus on healthcare because that's my background, but I think it can be useful for other people as well. So just slightly about me, like I said, I'm a final year medical student. During my clinical placements, I've looked into stroke data, pregnancy-related stuff, robotics. So I've kind of dealt with a lot of different formats of data. For my BSc in bioengineering, I looked into ECGs and denoising using autoencoders. I also recently founded a startup funded by Research England using speech data, and before that I spent about 2 years doing medical imaging mostly. So, kind of going back to what happens after you build an algorithm for deep learning, in healthcare it's quite difficult because you can have all these fancy prediction algorithms and all of these models telling the doctor to do something, but it's really difficult when you deploy into the real life. So you just imagine having a robot controlling everything, but in the deployment timeline we have a lot of things to consider. So, the first thing is missing data. So can anyone tell me what I mean by this and why this might be a problem in building models? Anyone? It's the simplest one, but... Alright, so missing data itself obviously is a problem in any kind of database, but when it comes to healthcare it becomes a very big issue because the healthcare data, we have clinicians and basically nurses logging in all of the different types of data, and in a lot of cases, because we are human, we get very lazy, or for whatever other reasons, more admin issues usually, and we tend to forget steps and when we write electronic health records and such. So when you actually look into real life data in healthcare, we tend to have a lot of missing data. There are ways of getting around that, but that's just one of the things that we do need to consider. After that is which of these are confounding factors and how do we build a robust model, but I'm not going to go into that in detail. What I do want to talk about more is about what we mean by interoperability and reproducibility in machine learning. So I'm sure that a lot of you have heard these two terms, and my first kind of take on what we mean by interpretable deep learning was that why do we even need it? Because when we first started having all of these AI algorithms used in radiology, people were like, oh, but we don't know why it's predicting that. We don't know why it's telling us that it has cancer, and therefore we can't use it in real life. But from my perspective as a medical student, when I got taught about radiology, they told me like you will just learn to see a nodule, you will just learn to see that this means cancer, and none of the radiologists could actually tell me why. So I was like, you can't tell me why. Why would you expect an AI algorithm to tell us why that means cancer? But that was my first take on it. Eventually, I kind of began to understand why it's very important when you start building algorithms and deploying it. That's what I kind of wanted to talk about later on. But before we go on further, there's a few other steps that you should consider when deploying any algorithm in real life. It's how it integrates into the real workflow. In my case, for healthcare, obviously, it will be the clinical workflow. And it's quite complicated because there's a lot of people using the algorithm. There's a lot of people, very, very busy people, and refuse to use anything that will require them additional efforts than they already put in. And I'm pretty sure that this will be kind of quite important in the success of any other product in any other field. So making people's life easier should be the top priority in most of your ideas. And the last one is dataset shift. So I'm not sure if that's the right terminology for it, but what I mean by that is that in healthcare, a lot of things change along with time. So we may start with a single data set, but along in a few years, the health policy might change, the understanding of a certain disease might change, and therefore what we need to interpret of the given database might change drastically. That's quite common in cancer as well, or any other public policy issues, and that leads to quite a difficult situation when it comes to deep learning models, because we would need to adapt our model to it. And such changes, when it happens suddenly, we won't have a lot of database to fine-tune our data, therefore we need a way to adapt our model with very few new data points. Or, so basically that's what I mean by data set shift. And this basically incurs cost. And if you can build a model that is robust to such data set shifts, or can easily incorporate and continuously learn over time, then that obviously gives you another advantage over other ideas. So what do we mean by interoperability and reproducibility? I did kind of hint at it. Can anyone tell me why you think it's important for patient safety and what they understand as being an interpretable model? I'm just going to throw this around if no one wants to answer. Anyone? Any volunteers? You guys are working on healthcare. I'm good. What do you think interpretable AI models mean?
Things that doctors can actually understand and use.
Okay. Would you like to give me a one-liner of your product or your idea?
Ours is basically getting breast cancer biopsies and using AI to determine whether or not tumors are present.
Okay. In that context, what would make it interpretable? What would a doctor want to know?
Whether or not the breast cancer cells have tumors in them.
Okay, and sure. So what kind of things are you looking at? Are you just looking at when you have the biopsy samples? Are you looking at the slices, the images itself?
Yeah.
Okay, and what are you outputting?
Well, yes or no.
Just yes or no. Okay, and how do I know how the algorithm makes the decision of that yes or no?
As a doctor?
Yeah, well, I mean, no, as in, like, when I look at the model and it says no, but I disagree, how would I know who's making the right call?
That's a good question.
Yes, that is a good question, because that's exactly what I mean by interpretability. So it basically is when you have a disagreement between the model and the user, in this case, the doctor, someone needs to make a call, right? So in kind of a more legal perspective, it might just end up being the clinician, just because you may not be able to blame the software and you may have to find a responsibility of making the call. But when you actually look into, so how do we make a model useful in that case, we need the model to be more transparent. So I think that's why interpretability is one of the key things that we do need to consider in healthcare. And along those lines, reproducibility is quite similar, because when you have one problem occurring in, let's say, patient A, and you try the same thing in patient B, but it gives something completely different. So obviously they may be different people, but given that everything should be similar, then you would expect similar results. But when things go wrong, then you need to be able to double check it. So you want to go back to patient A and patient B samples, and you take the sample again, and then it gets a different result this time. So something's going wrong, and it makes things very complicated if things don't reproduce. And reproducibility is generally a big issue in deep learning models for any application, especially reinforcement learning and such, because people tend to kind of pick and choose the best results, and that leads to issues in academia as well. But when it comes to healthcare, we can't just pick and choose and kind of overlook the issue of reproducibility, because it leads to direct patient safety issues. So that's kind of the most important bit that I wanted to talk about, that interpretability is not just kind of a phrase that we use because we just like to be fancy and we just like to understand everything about algorithms, but it is actually important because a lot of cases in biomedical data, we may have the sensor might go off, right? So, for example, the patient might have lots of ECG leads attached to them, but one or two might just get torn off as the patient moves around. And in such cases, part of the sensor data will be lost. And after that, what does our AI algorithm do? So you may just think, oh, it might just be harmless and give up an alarm. But like I said, doctors don't like that when they get false alarms because they tend to be very busy people and they don't like having their time wasted of false alarms. So, and even when they do, they want to go and be able to see that, oh, these data were missing, or this is the part that went wrong, and therefore our AI algorithm is predicting such results. So it makes everyone's life easier and also the patient safer, most importantly, if we can see exactly which part of the algorithm is leading to what kind of results. And I'm not going to go into how we actually deal with this. If you look into the literature, there's quite a lot of methods. None of them are quite perfect yet because we still don't have an exact concrete understanding of how we define interpretability. But the best kind of way of dealing with this is just trying to grasp the general understanding that kind of understand the importance of knowing why it is important for an algorithm to be transparent as much as possible and interpretable. So doctors make mistakes, so can algorithms. The importance and safety is that we need to be able to go back and fix it, and in order to fix it, we need to know where it went wrong. And that's just what I want to say about interpretability. And understanding clinical scenarios are important, and if anyone has any questions about how to deploy their healthcare algorithm or anything related to clinical stuff, then I am happy to answer further questions. Thank you.